yo, it's me, Factor and Frank, back showing you how to solve quadratic equations using square roots. Now here's a question. Why couldn't the construction worker put down his book? Because it was riveting.
First thing we're going to talk about is a square root. So the number a is a square root of b if a squared is equal to b. So you look down here and we have x squared is equal to 25. If you want to solve an equation like this, what you actually have to do is take the square root of both sides. Now the square root of x squared is going to be x, right? Because x squared equals x squared. And then over here, if I were to square root this side, the square root of 25, what squared equals 25? Well, that's either positive 5 or negative 5, right? Because if I were to plug in 5 here, 5 squared gives you 25. If I were to plug in negative 5 here, negative 5 squared also gives you 25. So those both would be the answers to this particular equation. Same thing over here. A squared is equal to 100. If I square root both sides, the square root of a squared is a. The square root of 100 would be plus or minus 10, because in this particular equation, if I plug in 10 for a, 10 squared is equal to 100. If I plug in negative 10, negative 10 squared is also equal to 100. Second term we're going to talk about is a perfect square. And those are just the squares of integers. So on this side, the right side of each of these equations, you can see your perfect squares. I need you to memorize these 1 through 400. There's only 20 of them, but you need to know them in order to eventually simplify radicals. So again, perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. You could memorize them, which I highly recommend, or if you ever forget them, you could just do it out, right? 16 times 16, 17 times 17, 18 times 18, and you'll get whatever the perfect square is.
What did the broken toilet say at the celebration? Let's get this party started! Oh, example time.
Now example 1 says solve each equation by finding square roots. If the equation has no real number solution, write no solution. So I have x squared is equal to 144. So this is the same thing as asking what number squared is equal to 144. To go the opposite direction, instead of squaring something, I need to square root it to get it to be just x. So what I'm going to do is square root both sides of this equation. And when I do a square root and a square, those two things are opposite, so they cancel each other out. That's why I did it. This just turns into x. Over here, you're going to see this plus or minus. The reason for that is because this is x squared. When I square root a variable that is squared, on the other side, I need to put plus or minus. The reason? Because over here, since this is squared, I could put in a positive number or a negative number. And when you square it, it'll still turn positive. That's why I need to account for both the positive version and the negative version. So what is the square root of 144? Well, 144 is 12 squared. So the square root of 12 squared, the square root and the square cancel each other out. That's how you just get 12. And again, it's plus or minus 12. Don't forget, you could always check your answer too by plugging in 12 and squaring it. Do you get 144? Yes. Plug in negative 12. Square it. Do you get 144? Yes. Right answers. Here, same thing. I need to get a by itself. And in order to get a by itself, I have to square root both sides. Because I'm square rooting a variable squared, on the other side, I need to put plus or minus. The square root and the square are going to cancel each other out. On the other side, what is the square root of 169? Well, 169 is 13 squared. And 13 squared, if I take the square root of that, the square root and the square cancel each other out and just give me 13. And again, plus or minus 13 because I square rooted a variable squared. For part B, doing the same thing. Here, I need to square root both sides. This square root and the square are going to cancel each other out. Over here, the square root of negative 49. What two numbers multiply together to make negative 49? They have to be the same number though, right? Well, you can't have two numbers that are the same number multiplied to make a negative. It just doesn't happen. In order to make a negative, one number has to be negative, one number has to be positive. So this, taking the square root of negative 49, you can't take the square root of a negative number and get a real answer. So what we say is no solution. Here, f squared is equal to 25 over 16. Again, in order to get f by itself, I need to square root both sides. Now, when I do that, I write a plus or minus because I square rooted a variable that was squared. On this side, when I square root a fraction, it's the same thing as square rooting the numerator and denominator separately. Now, what is the square root of 25? Well, 25 is 5 squared. So the square root of 5 squared, the square root and the square cancel each other out. I just get 5. In the denominator, what's the square root of 16? 16 is just 4 squared. So the square root of 4 squared, the square root and the square cancel each other out, I just get 4. So my answer would be f is equal to plus or minus 5 over 4.
What do you call a broken watch that clips to your belt? A waste of time. Hey, you try.
Okay, up here, I need to get q by itself, so I need to square root both sides. Again, because I'm square rooting a variable squared, I put plus or minus over here. Now you see I'm square rooting a negative number. We said in the previous slide, you can't have the same number multiplied by itself and get a negative number, because if you multiply a negative times a negative, it becomes a positive. You multiply a positive times a positive, it's positive. So you cannot take the square root of a negative number and get a real answer. So you write no solution. Over here, m squared is equal to 81. I'm going to square root both sides. Again, because I'm square rooting a variable that is squared, on the other side I need to put plus or minus. The square root of 81. 81 is 9 squared, and then the square root of 9 squared, the square root of the square cancel each other out, and I'm left with m is equal to plus or minus 9. For this one, I square root both sides. Again, plus or minus, don't forget that. The square root and the square over here cancel each other out. I'm just going to get c. On this side, 121 is the same as 11 squared. So the square root and the square cancel each other out. I'm just left with plus or minus 11 as your answer. Lastly here, d squared is equal to 225 over 9. Now, you could right away take the square root of both sides. Always check though, this fraction right here, I can simplify this. 225, I can divide by 9 and get 25. Now, that's easy. All I have to do is square root both sides. So the square root of d squared and the square root of 25. Remember to put plus or minus because I'm square rooting a variable that's squared. I then simplify this. 25 is the same as 5 squared, and then 5 squared, the square and the square root over here cancel each other out. I'm just left with plus or minus 5. Example 2 says solve each equation by finding square roots. So we're doing the same thing. This time, though, we're given something that looks like this. Ooh, that's interesting. How do I solve this? Well, the way you do this is you just get p squared by itself. So anytime you have something like this, you can just add the 196 to the other side, and then we have equations just like we had before. All I have to do is square root both sides. Remember to put the plus or minus over here. And what is the square root of 196? Well, 196 is the same as 14 squared. So the square root and the square cancel each other out. I'm just left with p is equal to plus or minus 14. Same thing here. In order to get a by itself, I want a. That's what I'm solving for. So I subtract this 27 to the other side. These cancel out, and over here, what's 36 minus 27? That's 9. So now I can solve this by taking the square root of both sides. Remember, anytime I take the square root of a variable squared, these are going to cancel each other out, and over here I have to put a plus or minus. Now what's the square root of 9? 9 is the same as 3 squared, so the square root and the square cancel each other out. I'm just left with plus or minus 3.
What state has the smallest drinks? Minnesota! Hey-ho, you try.
Okay, doing the same thing. Again, I want to solve for k, so I'm going to add this 400 to the other side. The reason I do that is because now I have k squared is equal to 400, so all I have to do to solve for k is take the square root of both sides. When I take the square root over here, because I'm square rooting a variable that's squared, I have to put plus or minus over here. Next, the square root and the square cancel each other out. Over here, the square root of 400 turns into 20, so k is equal to plus or minus 20. Again, you can always check your answer. You can plug in positive 20 for k, square it, subtract 400, you get 0. Plug in negative 20, square it, subtract 400, you get 0? Yes, so those are both your answers. Here, I subtract 49 from both sides, and I get k squared is equal to negative 4. Now, in order to solve this, I need to square root both sides, and you should already see a problem with this. I can't square root a negative number and get a real answer. So you say no solution. Example 3, same thing. We're solving for b. So how do I get b by itself? Well, I need to add this 16 to the other side, and then I need to get b by itself, so I need to get this 64 over to the other side. So I divide both sides by 64. Now, these are going to cancel each other out. I get b squared is equal to 16 over 64. This fraction right here, I can simplify this. I can actually divide each of these by 16. This divided by 16 is just 1. This divided by 16 is 4. So I get b squared is equal to 1/4. Now, to get b by itself, I got to get rid of this square. So I square root both sides. Remember, anytime you square root a variable that's squared, the other side has to be plus or minus. So it's going to look something like this. Now, when I square root 1/4, square rooting 1/4 is the same as square rooting the numerator and the denominator. What's the square root of 1? That's just 1. What's the square root of 4? Well, 4 is the same as 2 squared. So 2 squared, cancel out the square and the square root, and I'm just left with 2. So b is equal to plus or minus 1/2. Again, you can always check your answer by plugging in the positive version and then plugging in the negative version and seeing if you get 0 both times. For part B, doing the same thing, we want to get y by itself. So what we're going to do is we're going to subtract this 83 to the other side. What's 98 minus 83? That's going to be 15. And then I need to get y squared by itself still, so I have to divide both sides by 15. These 15s are going to cancel each other out. That's why we did it. Over here, what's 15 divided by 15? Oh, those also cancel each other out and just leave me with 1. So what is y squared equals 1? How do I solve that? Well, again, I have to square root both sides. And anytime you square root a variable squared, the other side has to be plus or minus. Now, what's the square root of 1? We already talked about this. It's just 1. That's super easy. So we get y is equal to plus or minus 1. Those are your answers.
Why didn't the worker buy Velcro? It was a total ripoff. You try.
Okay, again, we're solving for q, so we need to get q squared by itself. So let's add 20 to both sides. We then get 5q squared is equal to 20, so I got to get q squared by itself. I divide both sides by 5. These 5s are going to cancel each other out. Over here, 20 divided by 5 is going to be 4. Then I square root both sides. Anytime you square root a variable that's squared, you have to put plus or minus on the other side. Here, the square root of 4, we now know, hopefully, is 2. So we get q is equal to plus or minus 2. Here, again, I need to get z squared by itself. So I'm going to subtract 62 from both sides. I then get negative 19z squared is equal to 0. To get z squared by itself, I divide both sides by negative 19. What do you get when you have 0 divided by negative 19? Well, 0 divided by any number besides 0 is going to be 0. So we get z squared is equal to 0. I then square root both sides, and I get z is equal to plus or minus 0. Well, you don't have to put plus or minus 0 because 0 is neither positive nor negative. So your answer is just z is equal to 0. You can always check your answer by plugging that back in, and yes, that is correct. Now let's talk about estimating square roots. So when estimating the square root of a number, find the two perfect squares that the radicand is between. So here, we're going to find the two integers the following square root is between. Now, the radicand, if you forgot, is the number under the radical sign. So the radicand in this case is 105.27. So we need to think, remember back to our perfect squares. So what two perfect squares is this between? What perfect square would be less than 105.27? Well, a perfect square that would be less than 105.27 would be 100. So the square root of 105.27 would be greater than 100. But 105.27 would be less than what perfect square? So we need a perfect square that's greater than 105.27. The next one above 100 would be 121. So the square root of 121 then would be greater than the square root of 105.27. Therefore, we know the square root of 105.27 has to be between the square root of 100, which is 10, and the square root of 121, which is 11. So we can say the square root of 105.27 is between 10 and 11. That's how you estimate square roots. Now, example 4 says find which two integers the following square root is between. So we have the square root of 43.92. So we can't do that in our head. So what we're going to do is estimate what it's between. Well, we have to think about what perfect squares the radicand here, 43.92, is between. Well, I know 49 is a perfect square, right? So that must be bigger than that. So the square root of 49 would be on this side. What would be on this side? Well, what's the square root that's less than 49? I think it's 36. So we would go the square root of 43.92 has to be between the square root of 36 and the square root of 49. Now, what is the square root of 36? 36 is the same as 6 squared. So the square root and the square cancel each other out. You just get 6. Over here, the square root of 49, we now know is 7. So the square root of 43.92 has to be between 6 and 7. Here, the square root of 14.83. So we think, what perfect squares is this radicand between? So this is really close to 16, right? Which is bigger than that. So the square root of 16 would be bigger than the square root of 14.83. And then what perfect square is less than 16? Well, that would be 9. So we know that the square root of 14.83 has to be between the square root of 9 and the square root of 16. We know the square root of 9 now is 3. The square root of 16 is 4. So therefore, the square root of 14.83 has to be between 3 and 4.
Why did the worker wear sunglasses when it got hot outside? Because it made him feel a lot cooler. Hey-oh. You try.
Okay, doing the same thing. So the square root of 54.67, we have to think, what perfect squares is this radicand between? Well, 54 is really close to 64, so 64 would be right above it. And then what perfect square is right below that? Well, that's 49. So the square root of 54.67 is going to be between the square root of 49 and the square root of 64. Now, what's the square root of 49? That's 7. What's the square root of 64? That's 8. So the square root of 54.67 has to be between 7 and 8. Here, the square root of 134.21. So perfect squares that are close to that. Well, I know 144 is a perfect square. So we can say the square root of 144 has to be bigger than this. And then what's the perfect square that's less than 144? That's 121. So the square root of 134.21 has to be between the square root of 121 and the square root of 144. Square root of 121 we know is 11, and the square root of 144 we know is 12. So this number right here, the square root of 134.21, has to be between 11 and 12.